Okay, hello everyone. Good morning, good afternoon, and good evening to all. I hope you all are doing well. Dear authors and invited guests, welcome to the technical session 2A. I am Anisha Mishra, the moderator of this session. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you all to the first series of World Conference Information Systems for Business Management 2022 through Zoom. This series is an extension to our ICT 4SD series, and I hope you will enjoy the knowledgeable and interactive sessions through the day. There is a special note for all the presenters. You all will be given 12 minutes for your presentation and 3 minutes for question and answers. And on 10 minutes, I will raise a gentle reminder. There is another request to all the participants that you please stay connected with us till the closing of the session. And if you have any update or query, you can write it to me in the chat box. So just before we get started, I would like to introduce you all to the chair of this session, Professor Nitesh Bhatt. Okay, Dr. Nitesh Bhatt is professor and chairperson of Information Management area at Institute of Management, Nirma University, Ahmedabad. He holds MBA Marketing and PhD E-Governance degrees from ML Sukhadia University, India. He has also completed a 4-month faculty development program of IIM Ahmedabad and an online internet governance capacity building program of Diplo Foundation, Malta in year 2006. He has more than 22 years of research experience in academia, corporate training and research. He is a member of National Executive Committee of Special Interest Group on E-Governance set up by Computer Society of India. He is a life member of Computer Society of India and Indian Society for Training and Development. His research domains are e-governance, e-commerce, and enterprise applications. Professor Nitesh Bhatt, welcome to the session, sir.
Thank you, ma'am.
We also have another session chair for the session, but she will be late. So for now, we'll continue with the papers.
Before we invite the paper presenters, I, in my individual capacity, welcome all of you. And it will be very, very interesting session to listen to all of you and your wonderful research insights. So I exhort all of you, once the presentation is over within the scheduled time, if other participants also have some questions or suggestions, please don't hesitate, right? It will benefit each and every one. So we can learn from each other and we can share our valuable experiences too. So we can go with the first presentation, please. All the best.
Okay. So now we'll start with our first presenter. And the presenter name is Ike Dayan Octaviani, and the paper title is Fluctuating Small Data Imputation with Lang-Range Interpolation Based. Dear presenter, you may please start your presentation.
Okay, I will start my session. Good morning, good afternoon, good evening, ladies and gentlemen. Okay, first let me introduce myself. I'm Ike Dion Octaviani from Telkom University, Indonesia. And today I would like to present my research in data imputation, which has the title Fluctuating Small Data Imputation with Lagrange Interpolation Based. Okay, let's start from the background. And nowadays, the role of data more and more important than before. Many people talk about the phenomenon based on the data that they have, and big data is such a kind of data that is popular now. The data that we have can be used for data analysis, and the result can be used for predicting some behavior, for example. And then it can be used for clustering, and also it can be used for detection something like intrusion detection or anomaly detection and so on. The completeness of the data is the most important, because if there is the data that is missing, it may give a bad analysis result. And from this page, we can see that there is missing data in the graph, and the visualize is not good enough for the analysis process. Okay, back to when we talk about the data, and when we talk about big data, of course, there are small data, right? So this research has a scope in small data. When we talk about small data, what is the sample of the small data itself? Okay, let's see here. The small data can be gotten from for example, from the sensor data. That is, the sensor data that is running or streaming. When stream small data face the same problem, for example, the missing data in the range of the data, and when the sensor is a crucial thing, it can be dangerous. Let's say earthquake sensor detection, or tsunami sensor detection, or maybe air pressure in aviation detection, sensor detection. There are such example of the important sensor result, and when the data is missing, of course, it can interfere with the data analysis process, especially if the analysis occurs on live stream data. Okay, actually, there are many solutions for recover the missing data. Many methods that can be used for resolve the problem, or we can say it with data imputation. Data imputation is a process that is used for completing the missing data. There are many examples for the data imputation method. First of all, the method that is popular enough is ignoring or delete a row of data that is not complete. When there is a variable in a row of data that has a missing value, this method is delete the row, and analysis process just use the data which is complete. Of course, this method can give analysis result that is not optimal because we're losing some data which may important for us. And the next method is replacing the missing data with zero value. All the missing data is considered to have a value of zero, and this method is similar to the previous method, but the difference in this method, we have a value and the value is zero. Sure, this method is not enough for imputing the missing data. And then we have a basic statistic method that contains of mean, mode, and median. This mean is a method that is frequently used for imputing the missing data. And the last method is specific method, like implementing machine learning method, for example, or we can say it interpolation method, or other method that can be used for predicting any value between the known value. Okay, when we want to imputing the data, the process is as simple as this. This research has a time series data, and then the next process is check the data is if the data is complete or not. If the data is complete, so there is no problem, and we state the process is finished or end. But if there is a missing data or the data is not complete, the next process is interpolate it, and interpolation is a method that is used in this research. After we got the result from the interpolation process, we can replace the missing data with the value or imputing it and then finish the process. Okay, talk about interpolation. What is interpolation? Interpolation is a method that predicting an unknown value between the other known value in range of data. We separate the interpolation method into two kinds. The first one is spatiotemporal interpolation, and then the second is temporal interpolation. Spatiotemporal interpolation is interpolation method that can be used for the data that contains spatial data, such as latitude or longitude. And for the temporal interpolation, there is no spatial component. In spatiotemporal interpolation method, we have inverse distance weighting that using weight value in the calculation process. And then we have Kriging interpolation that is so popular now. And last, we have spline interpolation. And for the temporal interpolation, we have polynomial interpolation, which is the basic interpolation method. And then we have Lagrange interpolation, which is an extension of polynomial interpolation. And last, we have Newton interpolation. And in this research, focus on Lagrange interpolation for imputing the data and the data has no spatial data. The problem raised in this study consists of three types of missing data percentage. The first one is 10% of missing data, and then the second is 30% missing data, and the last 50% missing data. If a series of data has missing data visualized, it will be seen that the missing data gives a slight disturbance to the visualization. The greater the percentage of missing data, the more disturbed the visualization side. Of course, also with the result of analysis. Okay, take a look. The Lagrange interpolation formula. The Lagrange interpolation formula has a very different with the previous interpolation method or polynomial interpolation method. In polynomial interpolation method, we should store or remember or use the previous calculation result for the next process. But in Lagrange interpolation, we don't have to use previous or remember the previous calculation process. It is claimed that Lagrange interpolation can cut processing time because there is no process of storing the value of the previous calculation results. In Lagrange interpolation, we rely on summation and product notation to process the data. The other benefit used Lagrange interpolation is we can set how many degree that we will use based on the problem. Lagrange interpolation has n variable, different with polynomial interpolation that only has linear, quadratic, and cubic as their degree polynomial. In this research, we use 1, 2, and 3 degree for the polynomial because we want to compare the result with polynomial interpolation that is often used for imputing data, especially linear interpolation. And here is the result that we got from the experiment used with the same data and the same missing data percentage. Mostly, the calculation result between polynomial interpolation and Lagrange interpolation have similarities in the MSA result, especially in quadratic interpolation. However, Lagrange interpolation can outperform the result if the degree is increased to third degree, or we can say with cubic interpolation. Likewise, linear interpolation with a missing data percentage of 50% can be outperformed by Lagrange interpolation rather than polynomial interpolation. And the interpolation, the important notes for this research, if the position of the missing data is around the extrapolation, we can say it in the beginning or the end of the data series, then we must replace the missing value with the value right before or after the missing value. Okay. Because the calculation process in this research must avoid data position, that is, use values outside the data range, because it can give a bad result. And the process only applies to data position at the beginning or end of a data series. Okay, talk about the formula of Lagrange interpolation. We can feel confused to pick the position of the data for being the data reference. So we divide the composition of the use of the reference data with into two, which is 1 to m, and then the second one is 2 to m with n equal to 1 until 3. In addition, we divide the calculation process into two ways, namely A and B. For the A is for calculation process as it is, and for B is the calculation process using linear interpolation result for the reference data. In the end, the method in this study is divided into 4, namely 1A, 1B, and then 2A and 2B. From this method, we got the best method is in 1 to n method with type A of cubic interpolation, which means we don't need to change everything for the calculation process. And in the end, we got the conclusion that cubic Lagrange 1A is more suitable method for imputing missing data than others method in interpolation. And also Lagrange interpolation method is suitable and can be implemented for data imputation with fluctuating small data. Okay, thank you for your attention.
Anyone has any question for EK? Okay. EK, it was a good presentation and my best wishes. Are you a PhD student?
Yes.
Okay, so best wishes for your research. What do you mean by small data here?
Okay, small data here is sensor result
Huh?
from sensor data result that is running
That
or
is true. But
streaming.
when you say in terms of volume, in terms of storage, what is the differentiation between small data and medium size or large data?
Okay, because in this research we got what's that? The data from the sensor, and we separate the data with tumbling window in every let's say every 5 minutes. We process the data every 5 minutes, and when the data in 5 minutes, this is the small data because there is no stat the large amount of data in 5 minutes from the sensor data.
So this definition which you are giving, is it your definition or it's a standard definition of what is small data?
Okay, for this research, maybe it is from me because maybe I often say it with tiny data rather than small data
Okay.
because it is
You can
very less data.
you can think further. Your title is with Lagrange interpolation. Just
Yes,
are you aware why this name Lagrange? Why the term
because
Lagrange? Who was the Lagrange actually?
Lagrange is the founder of the Lagrange formula itself.
Hmm. So you
So
can
like Lagrange
you can-
interpolation is such a method that is already
hmm.
uh
He was a professor. He was from Italy, right? So very notable contribution is given by him. So you can read about his work, right?
uh
Okay, good,
can you okay?
good, and all the best. Thank you.
Thank you.
Thank you.
Thank you for your great presentation. And now I would like to invite our next presenter, Meng Wang, to present his
Yes.
paper on the title Workpiece Recognition Technology based on Improved SIFT Algorithm. Dear presenter, you may please start your presentation.
Okay. I will share my screen.
Yeah, Dr. Wang, welcome. Welcome and best wishes.
Good morning, good evening, and good afternoon, everyone. I'm Wang Meng. I'm from Technological University of the Philippines. And the topic of my presentation is workpiece recognition technology based on improved SIFT algorithm. In my presentation, we have these 4 parts. Part 1, introduction. Workpiece recognition is the use of computer vision technology to intelligently classify the target workpiece on the production line so that the industrial robot can efficiently and quickly complete the automatic sorting, assembly, handling, and processing of the workpiece to reduce the production cost and improve the industrial production efficiency. The workpiece recognition technology is essentially image processing and recognition. Image recognition refers to the technology of processing image to identify different targets and objects. Generally, industrial cameras are used to take pictures, and then processing and image matching is carried out according to the pictures. Therefore, the critical step of image recognition is image matching. There are many image matching methods. The fish-based matching method is a hot research topic because of its good noise resistance, high matching accuracy, and better robustness to object rotation, occlusion, and other problems. In this paper, problems and solutions, in our paper, we researched SFT, a SIFT algorithm, and this algorithm was proposed by Louis DG in 2004. It can adapt to different scales, illumination, and rotation angles, and have fine invariance and high matching accuracy. However, SFT SIFT algorithm also have apparent shortcomings. The descriptor dimension of fish points is too large, which leads to an increase in data volume and is time-consuming, which seriously affects the algorithm's efficiency. And the new feature descriptor is designed to reduce the dimension of the high-dimensional descriptor in the original algorithm. Then the fish points are divided into maximum and minimum. The distance between the fish points of the same subset between the two images is calculated to reduce the amount of calculations of image matching. Part 2, methodology. The safety algorithm is mainly used to describe and detect the local features in the image. It looks for the extreme points in the spatial scale and extracts their position, scale, and rotation invariance. The basic steps of SFT image recognition include feature injection, feature matching, determination of registration model, image sampling. Feature extraction and feature matching mainly include key point detection, local feature descriptor generation, and feature point matching. Figure 1 is flow chart of image recognition based on set. Algorithm improvement. Dimensionality reduction of feature descriptor. The original safety algorithm uses 256 pixels in the rectangular area, 15 around the feature points to determine the descriptor of the feature point. Each feature point generates a 128 dimensional descriptor. The amount of calculation is relatively large, and the image matching is time-consuming. In this paper, the algorithm simplifies in the feature descriptor, and the specific steps are as follows. Step 1, taking the feature point as the circle and taking 2 pixels, 4 pixels, and 6 pixels as the radius. The field is divided into 3 rings, according to the fact that the pixels closer to the feature point has a greater impact on the features, and the pixels farther from the feature points have a smaller impact on the features. This algorithm divides the rings with different distance into regions of different size to reduce the impact of peripheral pixels on the features. The ring with a radius of 6 pixels is equally divided into 4 regions. The ring with a radius of 4 pixels is equally divided into 8 regions. The ring with a radius of 2 pixels is equally divided into 15 regions. Step 2, the grid level of pixels in each region is normalized, and the average grid level is calculated to keep the illumination unchanged. Step 3, calculate the grid difference value for each subregion. And step 4, each feature point descriptor comprises a grid mean value and a grid difference value of all partitions. Each feature descriptor has 56 dimensions. Compared with the original safety algorithm, each feature descriptor reduced the data by 56%. The feature descriptor established by this algorithm makes full use of the grid information and the difference information in the field of feature points, reduces the dimension of the feature descriptor, and retains the essential characteristics of image, such as translation, scale, and rotation. Feature point matching and selection is also the second algorithm improvement. For matching 2 image feature points in the safety algorithm, the distance between the feature points of the 2 images needs to be calculated. Due to a large number of feature points in the image, the calculation amount of the distance between the feature points is relatively large. If the number of feature points of 2 images is m and n, respectively, the number of feature points distance is calculated as mn times in the theory. In safety algorithm, the feature points are the extreme points in the corresponding DOG. When the image changes the illumination, scale, and rotation, the feature points are generally still extreme and will not change. Aiming at the property of the feature points, this type of optimizes the distance calculation of two images as follows. The maximum and the minimum values are stored in two data sets. When the algorithm judges the extreme points according to DOG. When calculating the distance between two image feature points, it only needs to calculate the distance between two maximum sets and two minimum sets. In the best case, the maximum and minimum sets account for 50% respectively, and the distance times of feature points are a half million times. Part 3, results and discussion. The experiment uses safety algorithm and improved algorithm to find the target workpiece from the workpiece heap graph. Figure 3, A is target workpiece graph, and B is workpiece heap graph. The discussion results of scaling, rotating, and coloring of the target workpiece image using the safety algorithm and improved safety method. Figure 4, Figure 5, Figure 6, and Figure 7, 8, and 9 is a result compared with safety algorithm and improved algorithm. Although the original safety algorithm and improved algorithm are compared and analyzed in terms of the number of feature points, the number of create matching points, the create matching rate, and the time consuming. And in the table, we can see creating match rate is improved, and also the list time radio is also improved. And part 4, conclusions. In our paper, the dimensionality reduction of feature descriptor reduced from 128 dimensions of the original algorithm to 56 dimensions. Two feature point matching and selection reduced the amount of calculation by 50%. And according to the experimental results, the create matching rate is improved by 7%, and the time consumption of the algorithm is reduced by 10%. And later, we can consider parallelizing the implementation and operation of the algorithm to improve the real-time performance of the algorithm further. Thank you. That's all for my presentation.
Good work, Mang Wang.
Yes.
Any of the candidate or participant, any question? Okay. Can you go to the previous slide, please?
Yes.
Go to the previous slide. Previous, no, second, no, just before, not the first one, second last. Yes. So you have mentioned here that we can consider parallelizing the implementation of the algorithm to improve the real-time performance. So what do you intend to do in the future? How can you improve it further?
The real-time performance of the algorithm. In our paper, I now use the image from the camera, industrial camera, and we just test the two image use original safety algorithm and the improved algorithm. So in the future, we will research about the real-time image matching, and yes.
Go to those images, slide number 12 and 13. Previous one. Yes.
Yes.
Did you? So in your algorithm, you included these work pieces which are shown here. Whatever the photograph seen, have you used those as a workpiece or objects? Mang, for this experiment, did you use these objects, workpiece?
Yes, workpiece.
So you use you use these workpiece. I'm asking you a question. I'm asking you a question. Like you, there may be a lot of other researchers who might have used these techniques, Swift algorithm, new and old, for some other object. Have you studied any other article? Any other researcher who has worked on some other workpiece, let's say a cable or nut, or let's say water bottle or something like that? Have you come across anything where the results were different? Instead of 10% improvement, maybe 20% improvement or something like that?
I'm sorry.
Have you understood my question?
Yes, I understand your question.
Yeah. So what you can do, good. So what you can do is that along with your research, you can also do the research for existing papers which have been published, existing experiments which have been done in the similar area. So that will also provide you some useful insights. And that is how, when you said you would like to improve the algorithm, that will provide you some additional inputs.
Okay. Yes.
Yeah. Thank you. All the best.
Oh, thank you.
Thank you for your great presentation.
Thank you.
And moving further, I would like to invite our next presenter, Aditya Anirudh Tipre, to present his paper on the title Bidirectional DC Converter Based Energy Storage Method for Electric Vehicles. Dear presenter, you may please start your presentation.
Aditya, are you here?
Okay, I think he's not in the session.
Okay.
Yes, so we will move further to our next paper. And our next paper presenter is Rikita Chokshi, and the paper title is A Footstep to Image Deconvolution Technique for the Both Known and Unknown Blur Parameter. Dear presenter, you may please start your presentation.
Rikita, welcome. All the best. Rikita, are we audible to you? Rikita is here. Why don't you respond, Rikita? Anisha, you can message to her or you can call her, and in the meantime, we can go to the next one.
Okay, sure, sir. So now I would like to invite our next presenter, Zameer Ahmed Adhoni, to present his paper on the title Taxonomy for Classification of Cloud Service Paths Interoperability. Dear presenter, you may please start your presentation.
Rikita?
Yes, sir, I am now available.
Now you are available. Okay.
Can I start?
Hold on, please. If the next presenter, to whom already Madam as Anisha ji has called, if he is here, then let him do. Otherwise, you can do that.
Okay, sir, no worries. Actually, I was joining from different device. That way.
We can understand.
Okay, sorry, sir.
Anisha, I believe the next presenter, Zameer, is not here. He is not seen. Anisha?
Okay, sir. So we can let Rikita to present his
and let Rikita make the presentation.
Okay.
Rikita ji, all the best, please. Go ahead.
Thank you, sir. Yeah. Okay, sir, is it visible? My screen?
Yes, it is visible. Please go ahead.
Okay. So myself, Likita Chopsy. Good morning to all. I'm going to present about a step to image deconvolution technique for both of the parameters, that is known and unknown blur. So basically, I am working as an assistant professor and I am about to join PhD soon. So this is my overview. Okay. Okay. So this is the outline that I'm going to cover. So starting with the introduction part. So I'm talking about the image degradation. So basically in day-to-day life, we are capturing the images that get blurred due to some effect that is not about about to happen in our original image, and we don't want that in the output image. So that is one kind of the blur, or it can be some adversary effect, or it can be the noise of the image, right? So first of all, the image that is the original image that gets degraded or distorted due to the unwanted effect that we don't want in output image. So first image is get blurred. So because of the point spread function, degradation function, that is PSF, that I'm going to cover next. Because of that, original image become degraded and some of the additive noise that is present in the image. So basically, I am going to provide the approach how to recover that image so that we can remove the blur, that unnecessary effect from the image. And for that, I am going to apply the restoration technique, and then I will recover the original image based on that. So what is point spread function? So whenever any object source is present about the image, it gets blurred or degraded or distorted because of the point spread function, and it is convoluted with that point object and image gets blurred. So this is how our image becomes blurred because of that. So that is the responsible factor for distortion in our image. So G, that is the output and image that we are getting due to the getting blurred due to the point spread function. So there are different kind of the blur available. So when I'm talking about the degradation, in that we are having the different kind of the blur. So first we need to estimate which kind of the blur is there so that we can work for the restoration technique. So various kind of the blur are motion blur, Gaussian blur, out of focus blur, and average blur. So when we need to identify which kind of the blur is present, first we need to identify which kind of the type is there. So motion blur is basically because of the relative motion between the recording device and the captured image. Gaussian blur is somewhat like that when some control is needed over the blur effect. Out of focus blur is like that. It is the blurring of image due to the incorrect focus. And average blur because of the spikes in the image, and when the noise is present in the image, it is present over the image. So when blurred image is there, we will identify which kind of the blur is that. So these are the different parameters for the different type of the blur. After estimating the type of the blur, we need to identify which parameter of the blur is there. And based on that parameter, exactly identification and estimation of that, we can recover the original image. So for that, we need to estimate perfectly which kind of the blur is there and which kind of the parameter for that respective blur. So basically, image deconvolution technique that can be classified into two categories, blind deconvolution and non-blind. So what is the difference over here? Blind deconvolution technique is like that, in that we are not knowing anything about the blur or anything about the degradation function. And when we are talking about the non-blind deconvolution technique, we have some parameter available, or we are knowing the type of the blur because of which our image is degraded. So according to that, we have to classify them whether it is blind or non-blind. And based on the information available about the source image, we can apply the blind and non-blind deconvolution technique. So the basic difference is that in blind deconvolution technique, we are not knowing anything about the detail, that is the which kind of the PSF is there and which type of the blur is there. In non-blind deconvolution technique, we are knowing the type of the blur as well as the parameter. So blind deconvolution technique, as we are not knowing anything about that, it is somewhat like brute force approach. We have to trial and error. We have to guess the parameter and then we can apply them. So it is basically iterative approach. And non-blind deconvolution, in that we are knowing the noise or we are knowing the type of the blur and parameter. So directly we can apply for restoration of that kind of the image for the non-blind deconvolution. So it is the non-iterative approach. So what will be our approach in blind deconvolution method? First, we need to identify the blur type and parameter, and then we can apply the restoration technique. While in case of non-blind deconvolution, we can apply the technique based on the information available, that is of the blur type and what are the parameters of that blur. So this is what I have done about the literature survey. I have studied these papers, and based on that I have find some specification and scope, and based on that I can work further for finding the approach and best suitable technique for both known blur parameter and unknown blur parameter. So these are the literature survey about the paper, and some of the important work are that someone has discovered the technique based on the blind deconvolution, and someone has given the technique based on the non-blind deconvolution. Someone has estimated the point spread function to recover the image. Someone has given the blurred image without information available, and how to apply blind deconvolution technique. So my main objective is to provide a systematic way for obtaining good quality image that can be without blur, and using that image deconvolution technique we can get the deblurred image. So to demonstrate the beneficial architecture that can work for both known and unknown blur parameters. So this is overall architecture that I have proposed. So these are the basic steps that I am going to apply for recovering the image. So first step is to acquire an input blurred image. Then after getting that blurred image, I have to identify which kind of blur type is there and what is the PSF. So after estimating the blur type and PSF, I have to apply the image restoration technique. So now again, in image restoration, there are two approaches, blind deconvolution and non-blind deconvolution, as I talked. So based on the approach, if I have the available information, all the information are available, then I can go for non-blind deconvolution approach. And if information are not available, only directly blurred image is available, then I can go for blind deconvolution approach. So after identifying approach, I need to apply the restoration technique and get resultant output image. So after getting the output image, measure performance are used as PSNR and SSIM, that is peak signal to noise ratio and structural similarity index matrix. So based on that, I can compare the result. So I need to find the comparison between output image and source image, and based on this index ratio, I can find how much my result is clearer to original image. So based on that, I need to make the observation and final result that output image is this much nearer to original image. So what are the challenges when I surveyed about the previous work? So I find that to restore an image using blind deconvolution technique, that is very challenging task. But as it is not knowing that which kind of the blur is there, what is PSF, what are the blur parameters, so that all are not known. So to restore that kind of the image, it is very challenging task. So we need to find out accurate. We want accurate estimation and identification of the PSF and type of the blur. So it is very tough. So some existing algorithm are available for non-blind algorithm. In that, most famous algorithm is Richardson-UC algorithm. So in that, we must know the information about the noise, and then we can apply the restoration technique for image deconvolution. And in case of blind deconvolution, it is very tough because any information about blurring function is not known. So that is the main challenge. So what I have given the clear insight, a footstep for finding the image deconvolution technique in case of both known and unknown blur parameters. So various methods that are available already for restoring the blurred image and improve the image quality. We can compare that. Compared to non-blind technique, blind deconvolution technique is giving the better result. Though it is iterative, but it is yielding to better results. So when we are dealing in the real life, when we capture any image from the satellite, also we are using microscope. So in that, quality of the image matters a lot. So in doing the restoration of the image, we are main focusing on the quality of the image, and we need the better image that is almost nearer to original image. So it is better to use a blind image deconvolution approach for getting the good quality and getting the good result. So with every iteration, it is yielding more improving result. So in future, I am going to apply the post-processing algorithm that can be implemented with the same approach, and in that number of iteration can be also reduced, as blind deconvolution technique is based on the brute force approach and iterative. We need to also concern that the iteration that we are taking, that is not more. So to get the good result with the same approach and to reduce the number of iterations, that based on the applied algorithm, that is my main work in the future. So parameters that can be also first estimated for the blind deconvolution technique, that is PSF and type of the blur, and then need to recover the image. And after recovering the image, I will be measuring the PSNR and SSIS for getting the performance. So that is what from my side.
Anyone has any question for Miss Rikita? Rikita, go back to previous slide. Okay.
This, sir?
Yes, yes.
Okay.
So there are two conclusions you have mentioned. For
Yes.
example, compared to non-blind techniques, the blind convolution technique gives good result.
Yes.
And with every iteration, it results into a more promising result kind of thing, right?
Yes, sir.
What is the basis of these two conclusions?
Sir, that is what I have done in the survey from the existing work.
Yes. So I just so it is based on literature review, right?
Yes, yes, sir.
Right. So like the previous two presentations, have you conducted any experiment?
No,
Or are
sir.
you-
No, sir. That is the mine is the review paper. Actually, I am about to start PhD. I have not started, so I have
Yes.
worked based on the starting phase.
Okay. Okay.
Building
So
the
you have
background.
done. So you, Rikita, you have done good literature review, quite comprehensive, and I'm sure there may be many other which you might not have quoted.
Yes, sir. I
But-
have not put it all the
Yes, yes.
papers. I have only kept 9.
I can understand. But just only one question.
Yes, sir.
The two conclusions which you mentioned,
Yes, sir.
are these uniformly applicable
Yes, sir.
based on the
In many
object
of the
image,
papers, yes, sir.
or
In
there are some
many of-
contrasting, or are there some contrasting results also?
Actually, sir, in many of the paper, I have referred more than 100 papers. So in majority paper, they are saying that blind approach is better, though it is very tough.
Right. So there may be contrasting result also where the other way around is true.
Okay, sir.
So please try to find if there are any, let's say, where non-blind techniques are giving good result. If those are the cases, which are those situations?
Yes, sir. Yes, sir. And
Right,
sir,
so
I
you-
have one doubt. Can I, if you permit, then can I share it with you?
Tell me if I have competency, I will address.
Yes, sir. Actually, it is the problem of the data set, because for some of the satellite image, actually, I'm also trying this same implementation, but it is not yet completed. But because of the data set, I'm getting the different results. So what can I do for that?
I think when the best thing is that right now, you see, it's a time paucity is
Yes,
also there.
yes, yes.
Yes.
Yes,
So what
sir.
you can do in this particular case, you can get in touch with your seniors or your
Yes, yes.
the guide under whom you intend to do that.
Yes,
And
yes,
through
yes,
literature
sure, sir.
review, this can also be done. But otherwise, your LR is really appreciated, and the topic which you have chosen is also a good one, which has a lot of scope. So, Rikita, our best wishes for your future research endeavors.
Okay, okay. Thank you, sir. Thank you so
Thank you.
much for sharing your view and knowledge.
Yeah.
Thank you, sir.
Thank you, Rikita, for your great presentation. And moving further, I would like to invite our next presenter. And now Zamir is here, so he will be presenting his paper on the title, Taxonomy for Classification of Cloud Service Paths Interoperability. Dear presenter, you may please start your presentation.
Yeah, good afternoon, all.
Samir, welcome.
Yeah. I would like to share my presentation. Give me a moment. Can you see the presentation, sir?
Yes.
Yes. Yeah, good afternoon, all. My name is Zamir Ahmed Adoni, and I am here to present on my research work, which I have been currently doing, taxonomy for classification of cloud service for fast interoperability. The authors are Zamir Ahmed Adoni and Dr. Dayanand Lal. Okay, so these are the contents what we are going to see for the today's presentation: abstract, introduction, cloud interoperability issues, review of literature, fast level interoperability, taxonomy of fast interoperability, and conclusion. Okay, abstract is development of cloud is one of the major development in the string of developments. Okay, and
Zamir, you can skip this and go to the next.
Introduction. In brief, if you want, I will tell you, sir, what exactly I am planning to do. Okay, we are planning to achieve interoperability. What in the cloud, we have different providers like provider A, provider B, provider C. Okay, and we have different consumer A, consumer B, and consumer C. Okay, consumer A is using a service from provider A, and he is working on some objectives and all those things, but he would like to have the services from provider B also. Okay, but each cloud provider has their own standards, has their own frameworks, and has their own settings. Okay, so due to which there is a problem with all these consumers, so that they cannot use the services of different providers. Either they have to migrate the everything, okay, because the APIs and everything which is being configured in such a way that changing is little difficult. So our plan of our idea of the research is basically to providing a standard semantic framework to all. Okay, so everyone, if are following the same standards, okay, so moving from one cloud to another or using the same cloud services from different providers will be very helpful. This is the main basic ideas. We are going to provide a standard so that if everyone are following the same standard, so it will be easy for all the consumers. They are not locked in to use with the concepts or what their service has been provided. Okay, so this is what basically cloud interoperability means and what we want to do. So once the data has been used or shared from cloud A to cloud B, okay, it should be such a way the data or the services, whatever has been used, it should be interoperable so that they can use and all the services from both the cloud providers. This is the basic idea of our research. Okay, what are the issues what we are facing is that I told you are built on one cloud that have the capacity to be tested, deployed on other clouds, and should be operated on other clouds also. The major concern is managing the complexity of different tools or different cloud portability or whatever the data and the platform or the services they provide from cloud A to cloud B. These are the issues of interoperability because they are not following the standards. Okay, these are the literature review. Service models are broadly accepted. We have three things, that is software as a service, infrastructure as a service, and platform of service as a service. We are basically concentrating on platform as a service and to achieve interoperability in platform as a service part. PaaS mainly deals with deploying on the cloud infrastructure, the cloud client's application programs needed, services to the program, libraries, tools, etc. Okay, in brief, all the need is to ensure that the program what is installed there, it runs fine. Okay, cloud interoperability, there are certain standard agencies also, they have tried to follow certain standard or they have instructed certain standard, but the big companies, okay, in the view of losing their customer, they are unwilling to follow the standards, because if everyone follows the same standard, it gives a way to the customer that they can use multiple providers. So these companies are planning to lock in their consumers so that they can have their consumers for the future also. Okay, pass level interoperability. Cloud computing pass level interoperability means movement of data and its related services from one platform to another, provided the cloud vendors with different infrastructures without having to put more effort. Suppose I am using one service from cloud A, okay, and I want another service of the same type from cloud B. Okay, whatever the data, whatever the things I am using, I should be capable of using that services, and I don't have to make much more changes to the structure and all whatever I am currently using. Data movement will mean compatibility of the data among the different platforms, and service movement will mean that the service also, whichever services is moved from one cloud to another cloud, or which has been used services from one provider to another, it should work properly in both A, B, or C. Okay, so for this we are providing a taxonomy of pass interoperability so that the providers initially itself they can decide and tell that what level of interoperability they can provide to the consumers. So this taxonomy, this way of characteristic of all the services, everything is very important. Okay, is developed after considering all the essential features of the cloud. The different levels defined in the taxonomy is generated based on the dependencies. We'll see it in the diagram what we have done. Taxonomy is generated in the form of hierarchical structure. The taxonomy starts with the pass interoperability, which mainly depends on two major categories like domain and infrastructure. Okay, the pass service is the domain driven, and domain plays an important role in the categorization of this. The second category, what we have seen is, we'll see is infrastructure. Infrastructure has been bleed into the past, even though it's a platform, but it has been added into the infrastructure itself. It observed from various research and forums that infrastructure is considered as a separate service, but no, it holds business point of view. However, when the scenario is considered from interoperability point of view, the present situation doesn't allow complete bifurcation, that dividing the AS and PaaS separately. Hence, PaaS has been broadly classified into the infrastructure as a service. We'll see it with this is the PaaS level of interoperability or the classification or the taxonomy we have provided, so that the provider also have an idea and the consumer also have an idea if they are looking to move from one provider to another, what level of interoperability they can achieve, and what level of settings they have to do to their system. Okay, so that if you want to migrate from the services. Okay, these are the domains. What is required here are the different tools, environments, okay, programming languages, okay, installation, file format, okay, development, initiation of a child, dependencies, interaction of processes, and in the deployment, what program you are deploying, data application, okay, existing and expecting child for working, data operating system service, all these things comes under domain. Okay, and pass interoperability in classified with the infrastructure. What are the infrastructure like? Servers, network type, operating system, or if it is servers, what are the maximum servers available, what configuration of these servers are there. Next thing is about the storage. What is the capacity of the storage they are providing? What capacity of the storage we have, and how we can interoperate with the different providers. This is the requirement, so that each and every provider has to follow these type of standards. Okay, infrastructure is further categorized, as I've told you, servers, networks, and operating system. The maximum numbers of servers required, all those things. Compatibility of operating system is a major issue when the interoperation is considered. Storage capacity, type of format, and the speed also matters a lot in successful execution of the application. So basically what we have done in this paper is an extensive survey of platform as a service is surveyed, and taxonomy for classification of the services are deployed. Okay, the main reason for bleeding or entering both PaaS and IaaS into justified based on the present scenario. Okay, it is necessary to understand that the dependencies of these services, if they are to be made independent, need in the near future, which is related to which one and what is dependent to which, so that if they want to separate or use some other provider services, so they will have a clear idea that whether I want new servers, whether storage or the data, whether if I move from this as a provider to another, whether my data will be compatible, or can I use my services and can I use my servers or services or the data with another provider, how it works, all those things is the basic needs now. Hence, the study of these services and the hindrance of the service for complete interoperability in the cloud is necessary. Taxonomy in this paper is capable of putting cloud interoperability in order so as to help the developer decide on what level of interoperability they can plan to achieve even before they attempt for the applications. Okay, thank you. This is what the basic presentation, or this is the basic idea of our research is. Basically is a user is having a service and he is using from a service provider A, and he is interested in using the same service from service provider B. The main reason is whether it is possible or not. Okay, it is not able to, it is not possible because they are using different standards. Okay, so when all the providers are following a particular standardized standards, what we can say, then our services and our application and everything, if we migrate or we use new services, it will be helpful for the both the providers and the consumers. This is what is about my research. Thank you, sir.
Thank you. Anyone who has any question for this very, very contemporary research? Okay, Zamir, are you a student or you are a faculty? What exactly is the status?
I'm a research scholar.
So my best wishes.
Yeah.
Zamir, I have 3 questions.
Yes, sir.
First one, why do we need cloud-based interoperability? So let's say I am having a ERP system or website, and that is hosted on Google Cloud or Amazon Cloud. Why do I need to move from Amazon to Google or vice versa?
There are different services, sir, which Google is providing, which Amazon may not provide. Okay. So there are different services, or maybe there are certain areas. Now there are region-wise storage of. I will give you an example of a UK-based this thing. So they are not allowing their data to be stored anywhere else other than UK. Okay. Suppose a client is using some application which requires to host the data of the citizen of UK. Okay, their main condition is they use the services from any providers, but the main condition is they are not going to host the data of in another countries. Okay, so maybe there are different issues with the data. There are many things, sir. So that is the reason if one wants to use different service provider, different services, it should be compatible.
Okay. The second thing is this figure 1, you showed that classification, domain and infrastructure.
Yeah.
You only prepared that, or is it accessed from somewhere?
No, it has been prepared, sir. Okay, it is
you
already
only prepared that.
We had some certain things and we have modified it with related to the respected currently what is available.
So when you prepared this, did you consult or got it validated by talking to some of the industry experts who are working in the cloud domain?
No, so as of now, no, because we have a proposal, sir. Okay, we have with the research objectives. Objective number 1 is this itself. Okay, we have given them the proposal. We require certain data and for execution of all those things. Okay, what company A is providing and company B is providing. Okay, we have met with cloud providers, different cloud service providers. Okay, they are not ready to share their data. What we have done is we have given them our proposal and our idea that if you are going to follow these type of standards, okay, then only we have this. If you run with this, and the execution part and the running part will be easier for the provider. We have proposed them, so we are waiting for their response, and we'll see how well they are going to respond to our idea. Based on that, we are going to carry forward with this.
So one small suggestion is that, of course, this can be validated further.
Yeah.
But in computing, like we are having a binary 0 and 1, yes, no.
Yes. Sir.
So we can never reach to a situation where it's just a yes, no, whether it is interoperable or not.
Yes.
Always there will be a fuzzy or fluid kind of situation. Yes, perfectly interoperability exists, and another extreme is absence of interoperability.
Yes.
And of course, there will be a lot of levels in between where
Yes.
partial or major or something like that. So maybe you can think of developing some sort of scale,
Yes, sir.
right? So that can be one good
Because the
area.
complete interoperability is not possible. So we are
I
going to
agree.
plan only
I
for a
agree.
particular this
So
thing.
that's ideal scenario. That's
Mhm.
ideal scenario. So if it is 100% is not possible, maybe the maximum possibility is, let's say, 70%.
Yes.
So we can come up with that scale. What
Yeah.
do we mean by that 70% or 30 or 20 or something like that, right?
Yes.
So
Yes.
that can be one good area to work in the future.
Yeah.
All the best.
Yes. Thank you, sir. Thank you very much for your input.
Thank you for your great presentation.
Thank you.
And moving further, I would like to invite our next presenter, Anshuman Mishra, to present his paper on the title Intrusion Detection Using Feed-Forward Neural Network. Dear presenter, you may please start your presentation.
Tuman, welcome.
Hi, Mr. Nitesh. I'm so sorry I cannot open my camera. I will start sharing my presentation right now. So I am a recent graduate, undergrad graduate, and I have worked on this project, which involves detecting intrusion in a network using a neural network. The co-author of this paper is my guide, Dr. Vigneshwaran Pandey. He is a professor in the Department of Networking and Communications at SRM Institute of Science and Technology. So in this topic, we are going to first explore why an intrusion detection is required in a network and how a network is vulnerable to attacks. So this is going to be a very brief discussion on how network attacks happen. So in a corporate environment, you may have a lot of machines connected to a private network that will be belonging to that organization and may be vulnerable to different kind of attacks. So for example, Windows 7 had this exploit called Eternal Blue, and this was quite easily exploited by attackers who had created custom exploits to exploit this vulnerability. So as you can see here, you can hackers generally do use two ways to attack a network environment. One way is where they directly interact with the environment, and the other way is more discreet, where they don't have to interact with the environment to gather information on the systems they are going to attack. So these the two methods that they use are basically active and passive reconnaissance. So in most cases, passive reconnaissance is done because it doesn't leave any traces of the attacker being in the network or gathering information. And active is a very good method. However, it does leave a lot of traces while the network is being attacked by the attacker. So most of the network attacks that are occurring are broadly classified into three areas. There's denial of service attacks, which deny the service that's occurring in a particular website, or it could be a cloud service also. And then there is insider threats, which happen when people within the organization attack the organization that they're working for. This may be because they do have some credentials that they could use, or they could get higher authorization to stop services of those organizations. And then there are man-in-the-middle attacks. In these attacks, there is a person who's snooping inside the network and is trying to act as an imposter to gather network from the data and then uh, try to act as a normal functioning unit of the whole organization. So these attacks happen with an intrusion in the network, and this is why the intrusion detection systems are present to identify such intrusions in the network. So in the existing system, there are many researchers who have used uh, an algorithm, and they have trained it to identify some sort of attacks. However, there were some problems using these approaches where the lesser known attacks were not identified by these algorithms, or either the detection accuracy of some attacks was quite low. Also, some of them faced with the problem of the feature selection, which the features that they used were not the features that were used in current attacks. And one more one more approach that they used was actually kind of outdated. Some approaches were using pattern matching, which involved matching different kinds of attacks and their signatures, which was not expected uh, for the attacks that are happening today, as new attacks or zero-day exploits are created by attackers to evade such pattern matching intrusion detection systems. Further, there have been new methods such as using sequence models such as an RNN. So these models, they have a specific memory that they use to detect some of these kinds of attacks. However, they will not be able to regain this memory, or they will not be able to retrieve this long-term memory while uh, trying to detect these attacks, which may reduce their accuracy. And however, further, using old algorithms such as simple vector machines and random forests, they are only able to identify specific attacks, but not all attacks. So moving on, in my work, I have just used a data set and then pre-processed it. The pre-processing parts will be discussed in further slides, and also the features that were selected. And I have chosen 70% of the data as training data and 30% of that as test data. And in the prediction statistics, we use precision, recall, and accuracy, since they are the best metrics for measuring the accuracy for a supervised algorithm. So the algorithm that we have used is a simple artificial neural network. This is a classification problem, and that is why this artificial neural network is the best for this situation. And the diagram that you see is a diagram of a normal artificial neural network. This is not the exact model that we have used in our work. You can see there's an input layer and a hidden and an output layer. So in these three stages of processing, the input layers are basically based on the number of features you have. I have chosen 5 features in our work, so we will have 5 features, 5 input neurons, and we have chosen 2 hidden layers. So we'll have 2 columns of hidden layers here and 1 output neuron. So this is the mathematical functioning here that's happening. The inputs that we provide are marked as X, and W is the weight. So the weight is dependent upon the size of the input. And since we have used different pre-processing methods, the inputs are very small in number, and that is why the weights will also be small. If the inputs were very large in number, that would have taken time for the neural network to learn and classify the attacks, and that's why the specific pre-processing methods have been used, so that the neural network learns those numbers and can do a faster prediction. The output neuron provides a probability as an output, but we use a specific Python library called NumPy argmax, which makes sure that the output that is provided is in a form of a whole number. And since in this classification problem, we only have 2 outcomes, intrusive or benign data, I mean intrusive or benign network activity. So the output, if it's closer to 1, using the argmax function, it will be classified as 1, which is intrusive activity, and 0 would be non-intrusive activity or benign activity. So this is the image of the neural network that we have used. So you can see the green circles as the input neurons, and the 2 rows of blue neurons as the columns, and 1 output neuron, because since we only have a binary classification, we only require 1 output neuron. So in this stage, we had a data set of 48 features. We only used 5 features. The reason why we did this, because not all 48 of them had equal contribution in providing proper accuracy, and we were able to reduce these 48 features to 5 features using recursive feature elimination. Also, before we did the feature elimination process, we found out the places where data was unavailable in the data set or there were null values. We converted those to 0, as numbers would be more helpful for the neural network to learn. And we also brought the values to a specific range. This was done so that the neural network has an easier method of learning, and larger numbers will just cause the calculation to take larger times, and the processing time would be a lot more than expected. We did use label encoding because we did have string data in our data set. So we wanted a label encoded to each string data. And this was required so that the numbers that would be used to label each string would be helpful in determining what kind of data that is for the machine learning, or sorry, for the neural network. And later we split the data into 70% train and 30% test. And then we execute the model and find the precision metrics. So these were the settings that we used. These were obtained through trial and error methods. We have used the activation functions of ReLU and sigmoid because these were thought to be the best ones out there for getting the maximum output. So in the results and the discussion section, we use precision recall and F1. So the reason why we use these methods was because they obtain a very good image of what the output would be for a supervised learning algorithm. And as you can see, the formulas given below require true positive, true positive, false negative, and false positive values. And using these values, we find out the value for precision recall and F1. So these are the tables, and the values were obtained for the confusion matrix from the neural network. And using these values, we then calculate the precision recall and F1. So as you can see, that in this table, there are two sections, normal and anomalous data. So normal basically means benign and anomalous means intrusive. And we can see the precision for the threshold. So as we go closer to 1 basically meaning that the threshold is too high towards intrusive data, and lesser than 0.7 means the threshold is quite low and there will be higher chances of finding less intrusive samples. So we also used a precision recall curve. The point of using this was to find out the proper diagrammatic accuracy of the neural network. The ideal graph for this would be a line that is two lines intersecting each other at 90 degrees. As you can see the line here, there should be one line parallel to the x-axis and one line parallel to the y-axis, and they should be intersecting each other at 90 degrees on the top right. That would be the ideal graph. However, it is not like this, as this neural network has not performed as well as expected. However, it did perform close to 90% accuracy. So these are the references, and these were the 5 features that we used in the work. So source bytes are basically the source from which the bytes have been coming out of to the destination. So these may be the attacker machine generated bytes. The destination bytes are the bytes that were received by the victim PC, or it may be one of the gateway devices. So same service rate checks the type of the service that was attacked, and destination host same service rate checks the type of bytes that was sent to the service. So it may be a SYN packet, or it may be an acknowledged packet that was sent by the attacker to the victim to fool the victim device into sending out wrong information to the attacker. And flag is just a notification of showing whether the connection was established between the attacker or whether the connection was not established. So this was my presentation. Thank you all.
As usual, I'm asking other colleagues if you have some question to Anshuman. No. Anshuman, two questions. What was the data set? What was the size of it?
So the data set had around 6,000 values. We approximately it had around 6,000 values and 48 columns. So we reduced the size to 5 columns only, basically 5 features. And we used those 5 features that I just showed right now. These were the 5 columns that we used.
Right. So Anshuman, like you showed some literature. So there may be a lot of other scholars across the globe who might have worked on similar topic in the past, feed forward and intrusion detection. Yes.
Yes.
So what is your contribution, which is different from others?
So actually here the intrusion is based on these 5 features that have not been concentrated by other researchers. They have concentrated on the similar features, but they have concentrated on attacks that were present that day and that were already discovered by security professionals. So here you do not need to know the kind of attack that's coming, because there is a neural network that will check the data that you provide and it would tell you that it may be an intrusive data. However, it does not tell you what kind of attack that was happening, but it does tell you there is an intrusion in the system.
Okay, good. Thank you and all the best.
Thank you, sir.
Thank you, Anshuman, for your great presentation. And now moving further, we have our next presenter. So Aditya Anirudh Tipre, and he will be presenting his paper on the title Bidirectional DC converter based energy storage method for electric vehicles. Dear presenter, you may please start your presentation.
Very, very contemporary topic, electric vehicles, green energy.
Yeah. Hello. My screen is visible now?
Yes, it is visible. Please
Yes,
go ahead.
Aditya.
Yeah. Okay. So
Aditya, would you like to turn on your camera?
Yeah. Yes.
Please go ahead.
Yeah. Just a second. It's visible now?
Yes.
Yeah. Okay. So my topic is bidirectional DC-DC converter based energy storage method for electric vehicles. These are my contents. So basically the hybrid electric cars have the same advantage as hybrid cars, but the main difference
Aditya,
is
you can skip this slide, please.
okay. Okay. Introduction. So now I start my introduction. Hello. Hello.
Yeah, Aditya, go ahead. We can listen to you.
Yeah. Okay. India doesn't have enough petroleum to last for a long time. It is also at risk from the supply to crude oil and natural gases. Even so, India is now the third largest imports on the oil in the world after the US and China. Behind both of them, more than the 82% of the India's total oil has imports are made up from crude oil, and more than 45% are made up of natural gas. So more than the half of the petroleum products are used in cars. As a result, running them cars causes a lot of air pollutions, which has a big impact on our environment. It's because India has a lot of cars that run on petroleum products and that aren't electric. New technologies like that, the battery powered electric vehicles are becoming more popular in fight against the greenhouse has emission and air pollution. Plug-in hybrid cars are electric cars that are be changed with electricity from the inside source, like the energy electric grid. So this one is the BDC, that means the bidirectional controller with dual battery. So the proposed BDC topology are for dual battery energy storages which has the high voltage DC bus voltage ES1. Here we can see that, then ES2 to toggle on or off the current loops of ES1 and ES2. Two bidirectional control switches, switch ES1 and the second switch is ES2, are used in the converter structure to maximize the static voltage gain between two low voltage dual sources, VES1 and VES2, and high voltage DC bus charge pump capacitor CB is used as a voltage divider in combination with four active switches. That means that are the Q1, Q2, Q3, and Q4, and two phase inductors L1 and L2. Additionally, the added capacitors lowers the switch voltage nation and active switches and removes the need for the high duty ratio operation. Additionally, the three bidirectional power switches, that SES1, SES2 is shown in figure, operate in four quadrants and used to generate the transistor power between two voltages and dual sources. So additionally, to suppress either the positive or negative voltage, two metal oxide semiconductors field effect transistor, that means the MOSFETs in series, are used to execute this bidirectional converter transformer. To the proposed converters definition, in this table we can displace the conduction states of all power devices involved in each operation modes. To facilitate the comprehension, the four operational modes are here are shown. The four are the this one is the implementation. Then the several scientific disciplines and business, including the automobile industry, have from the uses of artificial intelligence. Intelligence control is a method that that makes use of various AI technologies such as generic algorithm, machine learning, neural networks, and physiologic to achieve its goals. A controller which have played the important role. So we for our project, for our research, we use the fuzzy model. Is a system fuzzy model is a system description that includes fuzzy quantities that are impressed in terms of fuzzy members. Is used for the express in terms of fuzzy members or fuzzy sets as composed to discrete quantities. The right selection of the number, type, and parameters of the fuzzy membership functions and rules is critical for obtaining the required performance. The examples of good selection is the ANFIS, that means the adaptive neuro-fuzzy interference system, is a system that combines the fuzzy quantitative approach with the adaptive capabilities of neural networks in order to achieve the required performance. So this is the model-based implementation for dual battery storage for electric vehicle is shown. This is the MATLAB Simulink, an example of an ANFIS controller. An example of an ANFIS controller. This neural network has some standard outputs that is dependent on the inputs. Therefore, the neural network must be trained in conjunction with the output. The neural network output is applied for the physiologic, which generates if-then rules and membership functions. So this is the when it comes to managing non-linear systems, the ANFIS controller is quite popular as a result when compared to traditional PID controllers that are already available in the markets and other controllers. This is best control available when it comes to temperature, water bath controllers. This controller comes in handy. Also the controller is used in aircraft to control them, and now the research is being conducted for intelligent planes that can learn on their own and takeoff and landing operations. These are the application for that. Then this is the ANFIS part. Here we can see the error and change in error input is given for the physiologic controller for ANFIS rule applications. The bidirectional DC to DC is possible using ANFIS because ANFIS is a mix of neural networks and physiologic, and because it provides precision to non-linear systems, it is considered to be a superior controller when compared to other controllers, and it's frequently utilized in industry. So fuzzy rule input and outputs are shown. The inputs are error and the change in error, and the outputs is duration variation. So rules for Suzhou type are shown. The screen for rules as per the membership functions. define using the fuzzy membership tools. The input data is reclassified or transformed to a 0 to 1 scale depending on its likelihood of being member of a predefined set of criteria. Here the input membership functions are shown. The 5 membership functions for the inputs are given. Then the output membership functions, for the 5 membership for outputs are shown. How we measure the confidence that the degree of truth of an input space according to our self-defined meaning of the values. That means the big, small, high, low, positive, negative, average, medium, and so on, as a significant impact on how we pick a membership functions. Membership functions for output bidirectional converter with hybrid electric storage systems are shown here. So in this figure, VM output and inductor current changing and discharging are shown. Several simulations and tests have been carried out. There were 2 loads for the high voltage and high voltage DC bus energy operation mode, and 2 sources for the low voltage DC source powering mode in a system designed in this research. Both we are used in current investigation. So shows the fluctuation are this figure shows the less fluctuations and smoother transitions in case of the mode changes. The outputs are shown, which shows the better transition and lesser distortion as compared to PI outputs. The output transition for inductor current are shown, which gives the less distortion, smoother waveforms. The performance comparisons of the proposed BDC and models presented in related studies are summarized in this table. The models propose a higher number of passive components than the proposed converter does. The model therein do not passes bidirectional flow capabilities, although the conversions in featured bidirectional power flow, their corresponding maximum conversion efficiencies were lower than that of the converter proposed in the study. Additionally, the voltage conversions ratio for proposed by BDC is higher than the model presented. So basically our conclusion is the government and manufacturers continue to agree on new electric vehicles market objectives, while the cost of manufacturing electric vehicles contribute to fall, making them more competitive with internal combustion vehicles. Lithium-ion batteries technology advance have been imported to the rise of electric cars, and further move on to electric driving will demand greatly improved battery outputs. A recent study of greenhouse as gas emissions related with battery manufacturers has produced a wide collection of results and implementations that energy storage devices are the brains of electric cars, since they determine their performance, strength, and driving range among other qualities. Due to growing on demand for new electric cars, the energy storage system must often maintain a high energy density in addition to high peak capacity. Nowadays, batteries and supercapacitors are often utilized as the energy storage system in industrial practices, since they are capable of supplying considerable quantities of energy and power. With the use of dual battery energy services are employed in this paper, as well as a bidirectional DC-DC converter for hybrid electric cars. Due to the variations associated with the uses of PI controllers, such systems have shorter lifespan. So the suggestion study using ANFIS and for the smoother transition and less distortions, resulting in a longer lifespan and greater accuracy for such storage devices. And both sets of findings were in accordance with prediction made by the steady and state analysis. A large number of active power MOSFETs used in the suggestion with BDC for the sake of convenience. So these are my references, and thank you.
Aditya, good work. I really appreciate.
Yeah.
The kind of the work which you are doing or you have done is really the need of the hour, and I wish people like you who are working, it will really improve the quality of life, environment, and the durability, and that will solve the petroleum
Since
crisis.
from 1 year, I'm working on EV itself from the Tata Nexon.
I really appreciate. Thank you very much. Anisha, please.
Thank you, Aditya, for your great presentation.
Thank you.
Okay, so now all the papers have ended, and I sincerely thank all the presenters for their excellent presentation and contribution in this session, and all the participants for being a part of this Word Conference. I hope the session was informative enough. We, on behalf of the whole team, thank you for your support during this version, and we will be happy to have you in the second version in 2023. All the presenters would be getting their digital certificates through email within 2 to 3 working days. Further, all the papers have already forwarded to Springer. The publication will be live within 6 months. So kindly cooperate with the team of ISBM. I also like to thank our session chair for chairing the session, Professor Nitesh Bhatt. Here is a small token of appreciation on behalf of the team of ISBM and Global Knowledge Research Foundation. Thank you for your valuable presence, sir.
Thank you. Just 1 or 2 minutes, Anisha, I would like to take.
Sure, sir.
So originally 6 papers were scheduled in this particular track session, and all the 6 papers have been presented, and I'm really happy about that. All these presenters are PhD scholars across the globe. So the division of 6 is that 4 were from India, 1 was from Indonesia, the first one, and the second presenter was from Philippines. So there was representation from 3 countries. A very good thing which I noted is that the topics chosen are very, very contemporary, right, and related to the real world problems. So these are related to AI or machine learning or cloud or electric vehicles, right? So as the title of this conference says, it's a world conference on information systems for business management. So it was actually represented by 3 countries. Topics were very, very state of the art related to information system and technology. But much more than the technology, what is important is its implications. So implications on the cost part, implications on resource requirement, implications on the performance of the system, right? User experiences, security, privacy. And the last session is about, let's say, which is having a societal impact in terms of size of battery and quality of life and so. So it was really, as Anisha said, it was informative and a lot of insightful things. And good luck to all the participants for your wonderful research. Please carry on this good work and all the best. And I'm happy with the quality of work which you have done. Thank you very much. And thanks to GR Foundation.
Thank you, sir, for your kind words. And now I request you all to please switch on your cameras for a quick snapshot of this virtual conference.
Zamir, Riddhi, Rikita, Anshuman.
Okay, thank you so much, everyone. Stay safe and take care.
Anisha, I am signing off.
Okay, sir, we are ending the meeting now.